Alright, in this tutorial we're going to go over the power rule of exponents. The previous two rules that we've gone over are the multiplication property, in which if you have any two bases with exponents that are being multiplied together, you simplify them by adding your exponents together. And then the most recent property was the division property, where if you have any two bases that are being divided, as long as those bases are the same, you can just combine them together by subtracting your exponents, x to the a minus b, and they be combined together. In the power rule, what this tells us is that when an exponential expression has its own expression, you can simplify the entire expression by multiplying your exponents. Multiplying the exponents. Sometimes you may hear this being called power to a power. If one exponent has its own exponent, or base to an exponent to another exponent, then you would just multiply those two exponents together. So this is the only one it's a little unique where you're not looking at for same bases in order to combine things together. You're just looking to see if some exponent expression is being raised to another exponent, and you would just multiply them together. So the property right here, x to the a power, is inside our parentheses, and then that entire thing is being raised to the b power. And you can simplify this b exponent on the outside by just multiplying your two exponents together, all under the same thing. So you're not rewriting the base only one time because it only starts one time. Nothing else is being combined together. So we're still following the rules of having our answers be in positive exponents, just like with our division property. The first one is fairly simple. A to the 6th power raised to the 7th. That can be simplified by just taking your 6 times 7 in your exponent position, which gives you a to the 42nd power. And this can also work with multiple different bases. Notice how none of these are the same, so we cannot combine these using our product property by adding the exponents together. What we can do, though, is take each of these exponential terms and multiply them, if you think of it similar to your distributive property, multiplying each one of these to the exponent on the outside. So our first term is a to the negative 5th times, is it just a regular 12, or is that a negative 12? That's a negative 12. So a to the negative 5th times negative 12. And then we have a b to the 7th times the negative 12. And c to the 5th, positive 5th, times negative 12. So we're going to multiply these things together. Negative 5 times negative 12 gives us a negative 60. B to the 7 times negative 12 is a b to the negative 84. That's supposed to be a negative 60. That is a negative because it's positive times negative, and the c is also going to be a negative because it's a positive 5 times a negative 12, which is a negative 60. Now remember, we have to have positive exponents, so we just know that if we have a negative exponent, we're going to move the entire thing down to the denominator. So the a to the 60 stays on top because it's positive. Then our denominator is going to have both our b to the 84 and c to the 60 because they were negatives up top. And we need to have positive exponents in all of our solutions.